I'm going to record this. I hope that's okay.
Yes, so Mr. Khan, thank you.
Great, great, great. Okay, welcome. Happy Thursday.
Welcome. Welcome.
All right.
Hello.
Bienvenido.
Hi.
Vámonos.
Hello,
Let's
Dominic.
go.
Let's go.
So let's start with a presentation of the problem and the mission. Would someone like to, well, let me put the problem and the mission up first.
I got it if you want me to.
Go ahead, Brent. Let me stop sharing.
Okay.
Thank you.
I just put them together. I know last time it was more over.
Excellent, Brent. Okay, thank you. So before a good engineer builds, they should have a clear focus. What's the problem and what's the mission? Who'd like to read the problem?
Okay, Alexa, can you read the problem? And maybe Jesus, can you read the mission?
Yeah, it is. I cannot see because I cannot see all.
Oh,
Because are there.
you need to move your chat. The window
Just
up.
grab the chat window at the top black bar and move it to the left. I have the same problem, Alexa.
You need teamwork to solve it problems, but some people are bad at teamwork.
Good. You need teamwork to solve important problems, but some people are not good or bad, as you said, at teamwork. Excellent, Alexa. Okay. Who was it, Fernanda, that's going to read the mission?
Jesus.
Jesus.
Build a machine that demonstrates teamwork to deliver candy.
Okay. Do we all understand the problem and the mission?
Yes.
Yes.
Good, good, good. Good starting point.
Yes.
So Ms. Fernanda is going to show us some of the work that you did over the past week. She has a collection of videos that I'm really excited to see.
Yeah, okay. I'm gonna share my screen with everybody.
The videos that were made in the other class were quite spectacular.
Some of them were really good. Well, most of them, they were really good. Okay, so this is from Andre.
Andre?
Here I have 2 coins of 10 pesos, but I need that in this cup have more weight than in this cup. So I'm gonna put 40 grams of salt.
That's great. Saying how many grams?
Terrific. How many grams? Excellent. Yo. Bravo. Nicely done. Way to go. Who is this?
This student, I can't remember who's this. They got a nickname, so.
Okay.
Okay, this student is July.
Oh, look at that.
Almost. Almost.
Show that again. Show that again.
Okay.
I think that is Renata Garcia.
That is Renata Garcia.
Renata. Success.
Yay.
Yes.
Great.
Bravo.
Okay, then this is Juan.
This is Juan.
They added music and everything.
Wow. Complete with music. Okay, Juan, looks like it's gonna work. Wow, this is very, very well built, Juan. I can see you cut very straight and everything is very neat. It's an example of how an architect would build a model. Yo!
Great.
Good going, Juan.
This is from Isabela.
Isabella. I like this, Isabella, because it's very colorful.
Yeah.
The presentation of your project is beautiful.
Colorful.
You are an artist in the making.
I want to see the mine.
What is your funnel? Is your funnel a bottle?
Yeah, she's using a
She uses a bottle and you poked a hole in the bottle cap? Cool. Cool.
Okay, it's starting to move. It is.
That one was Isabella.
Yeah. Okay. Nice.
Sofana.
Oh
Good
yeah,
going, Isabella.
this is
Oh, these are nice. They really registered the idea.
Some problems.
I can see this is all made with tape. It's difficult to do this with tape, so if you get this to work with tape, that's a good engineering solution. Nice.
this is from Jose Maria.
Jose Maria. Okay. Boy, they followed the building tips very well. They reinforced their platform with sticks. They made
I
the
want to
flaps
see
keep the
my
bottle straight.
project.
Good, Jose Maria.
Nice work. Nice work, Jose Maria. Bravo.
Mine. There's.
Okay. Go.
Great job, Alexa.
Success.
Thank you.
Success.
Next, this is from
That is mine.
It's tricky to make this work. You have to build carefully to make this funnel work. It's a lot harder than it looks.
yeah, making the hole is kind of tricky.
All right. Ole, ole.
Okay, this one is from
Carlos, it's of Carlos.
Okay. Yeah. Look at this. I really like the way
Regina.
they constructed the bottle. They took the bottom off the bottle and then they poked a hole in the bottle cap.
yes.
Very, very good.
This one is from Regina.
Regina.
Ready.
Boy, I would like to have a nice big blackboard like you have.
Your blackboard is really cool.
Yeah. I want one like that. Oh.
Okay, the video is a little bit too long, so I'm gonna go over a little bit farther.
Okay. This is all part of the engineering process. It takes a while to get it right.
And many ×2.
Okay.
She's finding out that maybe it's better to do it with salt. What were you using at the beginning, Refi? Sand?
I see you have a teammate helping you.
Like this. And now?
This is it.
I think that he's using artificial sand.
Oh, some kind of a. All right.
Okay.
Well done.
Well,
Marco.
this is from Marco.
Okay, Michael.
A coin of here. Here I this to see that the same way. Oh, and then we're gonna put it like this. I'm gonna take it. Right, and put.
Wow, it's really nice to see everyone's work. Very industrious students you have, Ms. Fernanda.
These are most of their videos.
Great, great. Okay, good going, guys.
Great job, everybody.
So we're going to present the next link in your chain reaction machine, the next member of your chain reaction team. And that's going to be a catapult to throw candy. So to introduce this, Brenda is going to show you a pumpkin chucker. How do you say pumpkin in China in Spanish? What's the word for pumpkin in Spanish?
Calabaza.
Alibasa.
Calabaza.
This is an alibasa chucker. And look at how they decorated the catapult. It's important that the catapult works, but it's equally important that it looks cool. Catapult chucker, the pumpkin chucker. Now they're setting the catapult. This is called a trebuchet catapult. It was invented back in the days of knights in shining armor.
Whoa.
Trebuchet catapult. Look at how far they threw the pumpkin. Must have been 100 meters. Yo.
Wow.
Wow.
Whoa.
Yo este nuevo video.
This is the pumpkin.
¿Cuál?
Pumpkin chucker.
Oh,
Go. Okay.
we're going
So-
to do that.
We're going to show you how to build a smaller catapult to throw candy.
We know.
Instead of a
Okay.
pumpkin, instead of a alibasa chucker, we're going to make a dulce chucker. Okay? So let me show you, Brent, first of all, can you cue up our catapult design? Here's a video of the catapult we're going to show you how to build.
Whoa.
Pretty simple, but you can throw a piece of candy across the room with this design. Okay, we're going to show you how to build that, but I'm going to show you a couple of catapults that were made by students your age in China. So let me share my screen. And let me go to, I'm going to show you first a catapult made by Owen. Look at how nicely he decorated his catapult.
Whoa.
He made many designs. He said he made about 4 different designs before he finally got it right. And look at this. His candy lands in a bowl. Brilliant. Let me show you it once more. Brent, can you delete the scribble or?
Delete the scribble. Oh yeah, yeah.
I'm going to show it to you once more.
Oh, you're host.
Oh, I'm the host. Okay. Stop. Hold on a second, guys.
I think if you make me co-host, like that.
Yeah. Hold on a second, Brent. Let me make Brent. It's Brent.
I'm mission control also. Okay, got it. Perfect.
Okay, great. Okay, so back to the videos. That was the catapult that landed right in the bucket, and that went 4 meters. They threw a coin 4 meters. And so here's a challenge. Here's another solution. Completely different design. Looks like sticks and tape. Sticks, tape, and string. And look at how he made his video slow motion. And he marked off on the sidewalk how far his coin goes. Past 7 meters. Okay. Here's that other catapult design. Bingo, success. All right, so what we're gonna do next is show you how to build the catapult. Brent, can you launch the catapult PowerPoint?
Sure.
And explain how the catapult is built?
All right, let me, I think I'm sharing influence mode. Okay, there we go. All right, so we're gonna show you how to.
Whoop, we just lost you, Brent.
Can you guys hear me? I think there's just background noise on the mics.
Okay.
Question, 1, 2, 3.
Yep, we're good, Brent.
Okay. You guys can see my screen?
Yeah, let me try to delete, mute the others. Yes, we can see your screen.
All right, I just muted all and I unmuted you, John.
Okay, thank you.
Okay. So to create a catapult, the first, let me just clear annotations.
It's helpful, guys, if you don't mark on the screen. Thank you.
Okay. Oh. Okay. So I'm just going to keep it where I can clear it fast down here.
Okay.
All right, so the first thing is the physics of how a catapult works. So the distance a catapult can launch something is a function of the length of its arm, the weight of the projectile, like the thing you're throwing, the arm force, like what pushes the arm to move forwards, and like how strong that is, and the angle of release, like when it lets go of the item it's holding. So if you think about throwing a football or a baseball or any kind of ball, the projectile weight is like how heavy the ball is. If you throw a bowling ball or you throw a baseball, you can throw one a lot further than the other one with the same amount of force. If you throw a bowling ball as hard as you throw a baseball, it's going to hit your foot. Then the arm force, picture this being how hard you throw something. So the arm force is on the other side of the lever, like the left side. and it's the force that kind of pushes to make the arm pivot. It's almost like a seesaw, except for it can go further down because it's not like equal length. And the more pressure on the arm, the further something will launch, the more force there will be. And then the angular release. I remember when I was really little and I would throw a ball and I just didn't throw it right and I kind of like hit the ground in front of me. I could throw it really hard and really fast and it might be a ball that should go really far. But if I don't let it go when I'm throwing like this and I throw it down by accident, it doesn't go very far. So those are the 4 functions that will determine how far a catapult can throw something.
Great, great, Brent.
Okay, so the first step, now these are our supplies and our tools. So we need a piece of cardboard, some foamy, a straw, 4 coffee stirrer sticks, a paper clip, and an 8-inch piece of string. And the tools we need are scissors, ruler, tape, and a hot glue gun. When you use a hot glue gun, be careful. It's really hot. Let your parents know you're going to use it and have their permission. Okay, so the first step after we assemble our tools and supplies is to glue 3 coffee stirrer sticks to the bottom of a piece of cardboard. So the cardboard is going to be the base, and the coffee stirrer sticks reinforce the base so it doesn't bend or like wobble and stuff like that. It keeps it nice, flat, and strong. So then the next part is the arm. The arm is the part that actually like flips up to throw something. And then there's rubber band stoppers. So the arm, just to kind of show you guys what this is gonna look like, the arm gets attached with those 2 big pieces of foam. Those get glued onto the stick and onto the base, and it acts as a hinge. Then the smaller pieces that you see, the thinner strips, we're gonna cut those in half. And you see we attach them to the middle coffee stirrer stick. Those are gonna be rubber band stoppers. Rubber bands will loop around and get caught on them. And then we add on the last little piece of foam onto the arm of the catapult. So as you see here, up here, from a side view, we have our hinge. There's 2 pieces to the hinge. The arm is in between. And then there's going to be 3 rubber band stoppers. 1, 2, and 3. So we talked about the force that will make a projectile launch. And the rubber bands that we add are going to be the force. Those rubber bands will loop around each side, and when you let go of it, when you have the rubber bands in place, the catapult arm will almost be straight up. So the logic is the rubber bands in the front. The rubber bands in the front is the force that pulls forwards. It's like the force that will launch the object. But the rubber band on the back side is going to be what stops the arm, because it's going to control the trajectory, or like the angle it throws at. It stops it kind of in the middle, so that way the projectile launches almost straight out of it. If you want to make a rubber band stronger, we have a technique for that. So what we do is I'll emulate it with a piece of wire I have laying around. Okay.
I like the way Brent uses his collection of premium quality junk to demo.
All right. So pretend this is my giant rubber band, right? This wire. I'm gonna spotlight myself just so it stays up. So this wire is my rubber band. And you see if I hold it, this is how big it is. But if I start twisting it, watch my hand that's twisting. You'll notice it's slowly getting closer and closer to the other side. So as you see, it begins to wind and it pulls it in. And if I loosen this, you'll see that it's longer. So essentially, because a rubber band is rubber and can stretch, when you pull it, it will stretch and it wants to go back to being small. If you twist it, you make the rubber band smaller, meaning when you pull it apart, there's more tension. The rubber band is trying harder to go back in faster. So it adds more force.
Great, great.
Okay.
So these are clever little tricks, guys, you can use to control the distance your candy will fly. And if you don't have coffee stirrer sticks, don't worry. You can improvise with chopsticks or any objects you can find around the house that are stiff and will strengthen your catapult. So be creative if you don't have exactly the right materials.
Yeah, like you could even use multiple layers of cardboard if you had no sticks.
Yep.
So like John said, creative. It could be plastic buckets that are trash at your house. You can cut a few strips of plastic. Anything. Just think about the end result you want. You want a strong rectangular base. It needs sticks coming out of it because you're going to use that to tape onto the table. And it needs somewhere to attach rubber bands. So just think about what we're doing as more of a system, like how it works. And the details, the supplies or details, they can always be swapped out. So the next part is to create the bucket that's going to hold the candy. The hand or the bucket is what we call it. So to do that, we have a small square piece of foam, little square piece of foamy, and we have the straw we mentioned. What we do is we're going to cut, I don't know if you guys can see my little webcam, but we cut a little slit out of the foam, and then we take those two parts and we kind of bend them into each other, almost like creating a cone, but you just don't make it as pronounced as a cone. Like this could turn into a funnel or a cone really easy. But the problem is, if it's like this, it's not going to launch well. So what we need to do is just bend it over a little bit, almost where it looks like a triangle, kind of, if you look at it from like this side, like a rounded triangle. And it can sit something inside of it. And then that's going to get launched. So after you do that and glue it, hot glue it, you then want to glue it to the straw. This allows you to attach it really easy to the arm of the catapult. So as you see here, the coffee stirrer stick goes into the straw, and now the arm is attached to it's extended and it has the cup on the end.
And this allows you to control the arm length. So you can make the arm really long by just putting the straw further out on the coffee stirrer stick. Mm-hmm.
And then the last part is the trigger. So for the catapult to work, especially in our chain reaction, we need a trigger. So the catapult needs to be held together, like the arm has to be pulled all the way back and stuck there. You pull the trigger and it releases. So the way this works is let's go to the video. The paper clip holds on the two pieces of like the coffee stirrer stick, the wood, above the rubber band stopper, like where the elastic is not. It holds those two coffee stirrer sticks together. And then when you pull the string, as you see here, it releases it. So it winds up the string, it pulls it, and it releases. And if we do that in slow motion, we can get a really good view of it. The video might be a little laggy, but I'm gonna play it really slow.
This is great. So we need to pull a string, guys, because other members of your chain reaction machine are gonna trigger the catapult by pulling a string. Cool. Okay, do we have any questions? Brent, thank you, that was brilliant.
Welcome.
Any questions about how this is built?
No.
Okay, and you're invited, you're encouraged to make your own catapult design if you can think you can build one that will throw candy even further. But I can tell you that I've seen this catapult built and it's thrown candy across the room. So, Ms. Fernanda, do you like to guide the kids through sort of a review and and apply the engineering that we've presented to some of the math and physics that you teach?
Yes, of course. Okay, remember that we made that you had a small homework after you built your machine, your sand timer? Yeah, do you remember?
Yeah.
Yes.
Okay, remember that you calculated the amount of salt that you needed to put in and to have in the paper cone? And was it different from the one that you had when you made the experiment? The calculations from the experiment? Were the grams different?
No.
Are you sure?
No. Yes.
Were they exactly the same?
No.
I don't know, you tell me.
No. No.
So when you made your math, it was exactly the same as in the experiment. Okay, for the other group, they were a little bit different. Why do you think that they were different? Were all machines the same?
No.
No? Okay, so
No.
you think, what is different between your friend's machines and yours?
The whole.
Okay, the hole. What happens with the hole? What is different?
One is more bigger and one is more smaller.
Okay, some holes are bigger and some holes are smaller. So
Yeah.
what will happen if some holes are bigger? What will happen with the salt?
Go faster.
It will be faster.
Okay. And what happens if the hole is smaller?
Go
Or like
slower.
it will stuck a little bit.
Okay. So will it take more time to go down or less time?
More.
less.
Less? Are
More.
you sure?
More.
Because the hole will be smaller, it'll take more time. Okay, what else is different between your machine and your friend's constructions? Besides the hole. Okay, Alexa, what else?
It can be more big, the funnel.
Okay, the funnel can be bigger, that's true. And what about the materials that you use? Not everybody use salt, right?
Yes.
Okay.
People I use salt.
Some
I try to use sugar.
okay.
I use sugar.
Okay. Do you think that will change the results of your experiment?
No.
No.
No, because there are 400 grams. No.
Well, but materials are different. So in some sort of way, that can change the results too, because it's not exactly the same, right?
So, Miss Fer,
Yes, Jesus?
that the sugar is more, can be more smaller. Small.
Can you repeat that, Jesus, please?
The sugar can be
400.
smaller than the salt. Heavier.
Yes, but they're the same, 400 grams.
Okay. All right. But that may change the results, right? Depending on the materials also that you use. What else is different? What else can you tell me? Did everybody use exactly the same materials for making?
No,
No.
Okay. Do you think that could change the
I
results?
don't use hot glue.
I don't know.
I don't think so.
Why? Why is it that you don't think so, Alexa?
I don't know.
Okay.
You don't know why.
Someone could use a cereal box and the other one can
A
use
bottle.
Cardboard.
All right.
Some persons use a funnel and some persons use a bottle.
Bottles. Okay. So all the things that change between one machine to another, remember what they are called? It's a word that starts with D, remember? all the remember that word?
The what?
The
Variables.
the variables, remember? All of these are variables, so that can make your results change. That is why maybe your friends and you don't have the same results that you have in the table that we made in your homework.
Teacher,
Yes, Alexa?
two of different the balance of other persons that they yours. It can be the balance because some persons put a ball and some persons only put the scale.
Yeah. For example, if you don't have the ball, of course you're gonna need more mass into your balance, right? In order to make it move. Yes or no?
Yes.
Yes, of course. Okay. So, does anybody have any other comments that you want to share?
No.
No?
I love the word and the concept of variables. Fernanda. Variables is a very, very important concept, not only in science, guys, but also in life, no? You got to know how to deal with the variables.
Of course.
Good lesson. All right. So your mission for next week, guys, is to build a catapult that throws projectile, candy in particular, the furthest. Let's see who can build a catapult that throws candy the furthest. And do any of you remember the 4 variables that can control the distance your candy will fly? What's one? One variable, Brent, maybe you can put the picture up of the
weight of
catapult
the
variable.
candy.
I'm sorry, say again. Throw candy. The weight, did I hear?
Weight of the candy.
The weight of the candy. Excellent. What's another variable that can control the distance of your catapult?
Sports.
Arm length.
The arm length?
Arm length.
Great. And another factor, another variable?
Angle of release.
And the angle of release. And the 4th variable?
Arm force.
Arm force. You got it. So when you're building your catapult, whether it's the design we showed you or your own design, think about those 4 variables and experiment, play with them. Remember one of the videos we showed you from China? That fellow Owen, he spent a whole day designing and redesigning his catapult until he got it to throw the candy 4 meters into a bowl. That's a hard challenge. So it's going to take some time, some experimentation with all the variables. Okay.
Sounds like fun, John.
Yeah, I would like to do this challenge.
I want to do it again. I want to do it also.
Okay, great. So,
Try it and then I'll send my video also.
I'll make mine. I haven't done mine, but I'll make mine.
okay, good. Okay, so Mariana and Fernanda, unless there's anything else, we could adjourn.
I think if nobody else has questions.
Oh, no.
No?
Let's get cooking on your catapults, guys. Start collecting your materials.
Yes.
And remember what Brent said, hot glue gun. The first word in hot glue gun is hot. That means be careful.
That's why I use cold glue.
Cold glue or tape, yep. Okay, but it's good to know how to use a hot glue gun. A hot glue gun is a cool tool. It's a hot tool. Learn to use it carefully.
I will send instructions. I will post them in Google Classroom so that everybody can see them.
Yep.
Remember that this will be your project. when you come back from Easter break. Okay?
Okay.
Yeah.
You have 3 weeks, guys, to build a catapult.
How
And we'll
much?
send you the instructions. Okay.
3 weeks.
Happy catapulting.
But we can do it.
You can do it. I like that spirit. We can do it. Great motto. Okay. Fernanda, Mariana, thank you. Brent,
Okay.
great.
Thank you,
Okay,
John.
guys,
Thank
loved
you,
your
Brent.
videos. Keep doing what you're doing.
Yes, you're doing a great job.
You're
Yeah.
doing a super awesome job.
You have a bright future.
Happy Easter, John.
Thank you. Happy Easter to you. I'm going to be looking for
Goodbye.
I got chocolate bunnies. I got plenty of chocolates.
chocolate bunnies are better than real bunnies.
Okay.
Real bunnies make a mess.
Bunny.
I had a bunny one time and he ate all my electrical wires.
I bet you wish you had a
That
tough
happens
bunny.
with my cats.
All
That
right.
happens with my 4-year-old.
Okay.
Just tangle up in them and pulls. I'm like, no!
Okay.
Don't unplug it. The battery's dead. Just kidding.
No es por eso.
Okay, to be continued in 3 weeks. Adios. Que
Bye.
pasen un
Bye.
buen vacación.
Goodbye.
Bye.
Bye.
Bye. Okay.
John, look at this.
20